Ali Choucry, Cairo University, Egypt.
So let me start with a true story. Scott Choucry had a car accident and he remained in a coma for more than 12 years. A doctor started a bold experiment in which he would ask Scott a series of questions and measures his brain activity. And amazingly, Scott was replying with his brain waves. So the two made a system. If Scott wants to say yes, he thinks about moving inside his house. If he wants to say no, he thinks about playing tennis outside. And then the doctor asked him the most important question, Scott, are you in pain? And he replied, no. So, breaking the wall of the irreparable mind, our brain, our most valuable asset, why can't we repair it? So this is your normal brain. This is your brain after an insult, and you can see here these red waves are waves of destruction. They tell your brain cells, do not repair yourself, do not regenerate, just die. Many of the tested drugs targets one or few of these mechanisms, but they leave the brain environment pretty much unchanged. The other line of therapy is stem cells. These versatile cells that can grow and transform into any type of cells you need, including brain cells. However, they fail to deliver on this potential, and this image might explain why, because you should think of stem cells as a seed, and you can't plant a seed in such an inhospitable environment and expect a fruit. So if you're not lost already, in my work, I use the drug, let's call it the G drug. Not only did it prevent many of these red waves, it actually stimulated the formation of blue waves, waves of regeneration, repair, and differentiation. And it did so by interacting with 3 major protein systems, controlling the activities of more than 10 different proteins, all together governing life and death decision in the brain. And this was associated with an improvement in learning and memory function. More amazingly, some of these proteins were previously shown to actually support and stimulate the growth of stem cells. So the idea becomes clear. Neither should be used alone. First, you should use the G drug to transform the red brain into a blue brain, and then use stem cells to exploit this now hospitable environment to grow and repopulate the brain. So, our blue and green brain model, how many people would that help? Let's see 3 famous conditions: stroke, Alzheimer's, and Parkinson's. Stroke attacks more than 15 million people a year, leaving more than 5 million permanently disabled, while Alzheimer's will claim 115 million and Parkinson's at least 8 million. The cost is also huge, with Parkinson's costing 10 billion US dollar. Alzheimer's will reach 1 trillion and stroke $2.2 trillion. And if you think that is bad, well, think again, because except for Alzheimer's, these are just the projected costs in the United States. The worldwide cost will be much, much higher. So our blue and green brain model, hopefully helping these people, helping Scott, and helping us break the wall of the irreparable mind. Thank you.